Hi, today I like to show you how rubbing your sausage on a radio antenna tower you can hear the radio station playing as shown in a video of my friend Jay from Plasma Channel.
First of all, remember he's a Roman citizen. That's why.
In fact, you can do it at home too. All you need is a radio receiver and a sausage, or in my case a pickle, which is basically filled with conductive liquid. Then you just ground your pickle and turn on your radio. Then we touch the antenna. Oh! I hear it, but the pickle makes it a bit chaotic. Let's go direct. There we are.
Winds, quite damaging winds earlier this morning with the heavy rain.
See? The sounds are coming from the arcs that are basically demodulating the radio signals into audible frequency. Oh, and of course you need a bunch of additional circuits and equipment to make this happen. With the AM radio being the source of audio signal, we feed into our circuit, see? Let me... I guess the circuit overheated. I think I'll fix it now. In the meanwhile, you will greatly benefit from my sponsor Brilliant, because it's time for you to become even smarter through thousands of Brilliant's interactive lessons on math, data analysis, computing and science for free for 30 days. Signing up from my link below. More at the end. Okay, you may remember this. No, this is not what in the movie Matrix Mr. Anderson bugged Neo with. It is the gut of my electric magic wand I made a while back, and what it does is it creates 5 to 10 kilovolts of AC output at around 70 kilohertz. Of course, you see, it doesn't make much noise because we can't hear 70 kilohertz. Otherwise, it would be very loud as it slaps the air on and off. Which reminds me, although 70 kilohertz can burn, it is well above the level of electrocution by shocking. So I should be able to hold on to the pickle direct. And that's why, kids, we must never touch AM radio towers. Not only their power is much more than this that can burn you to a crisp, but also it is a powerful carrier signal, 70 kilohertz in my case, modulated at audible frequency, so it has powerful low frequency components that can shock the shit out of you and you won't be able to let go of the antenna while cooking to perfection. Anyway, from my device here running on a battery, we are outputting a fixed AC energy we can't hear. But if we change the output energy at audible frequency, the air expands and contracts at audible frequency and we can hear it. I've done a similar thing in my musical Tesla coil in my over 9-year-old video, with a different circuit though. In that one, I changed the pulse width modulation of the switching frequency. I switched the primary of the Tesla. Just watch that video. Here, I already have this circuit and I don't want to modify it. But I know one thing, in this, same as things like a motor or a lamp, if we change the supply voltage lower or higher, the output power goes lower or higher. So what I do is, I change the supply voltage at an audible frequency and the arc's output energy changes at that frequency and I can hear it. This is exactly what AM or amplitude modulation is and why you can hear sound in the sausage on tower trick. You might ask, well, an AM signal is still at very high frequency. How does an arc demodulate it and make it audible? Well, to demodulate AM, all you need is a diode to rectify it first, and then a resistor capacitor to create a voltage that rides on the signal peak and filters high frequency, and you're left with audio. Now, if you look at an incandescent light bulb in slow motion, you see, although it runs on say 60 Hz, the light blinks at 120 Hz, because both positive and negative AC peaks create positive power. Same as what the arc does, so it acts like a full wave rectifier. And of course, air heats and cools at a much slower rate than the carrier frequency, so it acts like a low-pass filter too. Air is basically an AM demodulator. It's very simple, so simple you can do it at home without all those equipment. All you need is one of these arc lighters. Let's see if I can do it to this one. If we open it, It's running on a single cell lithium battery running on 3.7 volt average. So to change the arc output power, I need to change the supply voltage by making the audio signal to ride on this DC supply voltage. So all we need is to throw a 9 volt battery and some resistors and capacitors and sprinkle them on the circuit and massage. And here's what we get. Look at it! I hooked up my radio to my lighter. Let's listen to it.
应该是6岁，当时是什么样的原因要去参加这样的比赛？
You can actually understand what it's saying.
是，然后我的老师
If you speak Chinese, that is. You listen to it.
That something needs to be looked at, and only by looking at it from an independent perspective and being able
Doesn't sound bad at all. It's a little bit dim, but
to make those kind of changes.
pretty cool, eh?
Politics that can go.
I mean, it's so simple. You can make it at home too. All you need to do is watch the rest of the video. We need to use a MOSFET. I talked about it in my previous video, but basically it is like a resistor when it's on. The higher the gate source voltage, the lower the resistance. Imagine we have a load on the source. Raising the gate voltage reduces the drain source resistance, opening the floodgates for more current through the load, raising the load voltage. Reducing the gate voltage drops the load voltage. So tuning the gate, we can tune the load between 0 to the battery voltage maximum. Here I have a MOSFET with 4 volt DC on the drain, seen as the yellow line, and I supply a triangular wave on the gate between 0 to 8 volts, which is the green line, and the source voltage is blue. Only when the gate voltage rises above the MOSFET threshold voltage, source voltage starts to rise up to the 4 volt drain voltage when the drain source resistance is very small, like a short circuit. Well, here's the circuit if you don't care about how it works and just want to slap it together and make it work to show it to your mom, so she calls you a genius and the pride of the country and future generations. If your mom says all that, you might be a male Iranian guy with a golden p, as Max Amini puts it. But just in case your mom asks for details, we disconnect the battery positive from the lighter and connect it to the MOSFET drain and supply the lighter through the source. The gate resistors divide the 9 volt battery to around 6.5 volts, so we get around 3 volts to the lighter, depending on the MOSFET you pick. We feed the audio signal from radio or whatever has an audio jack to the MOSFET gate through a capacitor to isolate the DC levels. Oh, and the reason a MOSFET is more convenient here compared to a BJT transistor is that the gate of the MOSFET virtually draws no current from the circuit, so it doesn't affect our audio signal or DC levels. We also add a small capacitor between source to the ground to absorb those pesky high-frequency reverse currents generated by circuits that switch inductance. This keeps the supply voltage clean without filtering audio. You just have to make sure your capacitor can handle those high ripple currents. Maybe that's why my capacitor blew up at the beginning. And that, my friends, results in the supply voltage to change by audio signal, which modulates the lighter's arc output power, and you can hear it. Like this! Can you hear it? Well, it's a little bit dim. Right now I'm holding the microphone in my hand so you can pick up the sound from it. Otherwise, it's not terrible.
It was very funny. Funny to me. I got a call from.
Oh, maybe if I burn the pickle with the arcs, it sounds a little bit louder. Ouch! Forgot about those lower frequency components of the arcs. Now go ahead, my children, make your own musical lighters with disappointingly dim but nevertheless very cool sound level outputs, knowing that you can always scale it up. Like how you can scale up your skills by adding knowledge to your brain thanks to my sponsor Brilliant. Why do you think I keep picking Brilliant as my sponsor? Because I truly believe what they provide is very valuable to everyone. They teach some of the most important knowledge on math, data analysis, programming, AI, and more, and they keep adding to their library. And they teach in the most effective way possible online, which is through interactivity and hands-on problem solving. So not only does it feel fun to learn, but also the fact that you learn so easily and retain all that information is a huge encouragement that keeps you going. You become a better thinker who solves complex problems through all the problem-solving skills you pick up at Brilliant. And rather than trying to memorize complex concepts and equations, you know how things work and can derive results over and over again. All you need is to make it a habit of learning for a few minutes every day, and before you know it, you become an expert in what you need personally or professionally. Sign up using my link brilliant.org/electroboom to see what I mean for yourselves through the 30-day free trial. See how good Brilliant is, not just for yourselves, but for a vast range of age and skill. Then you will stay forever, especially since through my link you get a lifetime 20% off Brilliant's annual premium subscription. Enjoy the growth, and thank you for watching.